Alrighty, so scientific notation. I know you've seen this topic before, so don't pretend you haven't. My expectation, though, here is that you know it already, kind of, and that you're able to move forward with it. So this is not new information for you at any point. We're going to do some multiplying and dividing with it. That part will probably be new. So as a reminder, scientific notation. A number in the form of a times 10 to the n power, where a is between 1 and 10. Notice it's between 1 all the way up to, but not including 10, so like 9.99999. And the n is an integer, it's a power. Used to write very large or very small numbers, easy to multiply and divide in this form. And I'll show you what I mean by that here towards the end. So again, as a reminder, scientific notation, something like 1 or 2 point rather, let's do that. 2.38 times 10 to the fourth power, or 6.93 times 10 to the negative 3 power. Scientific notation. Standard notation is the usual form for representing numbers, like the number, let's say 6,321, right? That's a standard number. Or we could say 4,203,000, or we could say something like, now I know I'll write the zeros here and you want to say 0.00042, right? This is, remember how to read these? So tenths, hundredths, thousandths, 10,000ths, 100,000ths, so 4,200,000ths, right? Standard notation. And we're going to practice going back and forth between scientific and standard notation. Okay, so let's talk about multiplying in scientific notation. What that means, okay, let me give you a nice example. It means I'm going to take two numbers that are in scientific notation, or maybe one that isn't, and I'm going to multiply them. So I'm going to have 9.3 times 10 to the third power. Multiply that by 2.0, if you prefer, times 10 to the second power. Now, again, this is something you could put them into standard notation, move them around, but I'm going to show you to do it using scientific notation. First things first, you multiply the two numbers that are in the front, right? So 9.3 times 2. That comes out to be 18.6. Then, so you don't trust me, you can try it, right? Then take the 10 to the third and 10 squared and use your powers of exponents, right? So multiplication of powers, that's what I'm trying to say. Multiplication of exponents. I'll eventually spit it out. Technically, this is 10 to the third times 10 squared, same base. So this is 10 to the fifth power. So it looks pretty easy, right? 18.6 times 10 to the fifth. And you go, oh, wait a minute. That's not scientific notation, because this 18.6 is not right between 1 and 10. So now here's what I do. So again, this part was easy, right? 9.3 times 2, 10 to the third, 10 squared, 10 to the fifth. All I have to do now is look at this first number. If it's not in scientific notation, write it that way. 1.86 times 10 to the first. Then bring down your 10 to the fifth. 1.86 is definitely ready for scientific notation, right? 10 to the first times 10 to the fifth, we all know, is 10 to the sixth. And that's it. I just multiplied in scientific notation. Now the thing is, if you don't believe this, this is the right answer, and I checked it just to make sure. If you convert the first numbers we started with, the 9.3, right, times 10 to the third, and 2 times 10 to the squared, into standard notation, then multiply, and then convert to scientific notation, you'll get this number, which I think is, 1,860,000. Yeah, so there you go. That's multiplying in scientific notation. We'll do lots of practice at it, but this is a nice example for you. Okay, so dividing in scientific notation. Just kind of made this problem up. I have 1.65 times 10 to the third divided by 3.3 times 10 to the fourth. So again, we just divide the front numbers, divide the numbers of the exponents, right? Same base. And then we turn it back into scientific notation. So 1.65 divided by 3.3 is the number 0.5. Don't believe me? Check it out. 0.5. Now, we all know our rules. 10 to the third divided by 10 to the fourth. That's 10 to the 3 minus 4. It's a 4, I promise. Or 10 to the negative 1. So 0.5 times 10 to the negative 1. Hey, that looks pretty good. Except, now again, if this were 5 times 10 to the negative 1, you could quit. Well, here's the exception. This is not in scientific notation because this has to be between 1 and 10 in the front here. So I rewrite the front number in scientific notation, which becomes 5 times 10 to the negative 1 times, and bring down your 10 to the other 10 to the negative 1. So I'm going to get 5 times 10 to the negative 2, which is, by the way, in standard notation, 0.05, right? And there you go. Dividing in scientific notation. Really wish I could spit that out in one shot. But anyway, there you go.